Section 6 is called function operations. It's basically working with two different functions with your normal operations of addition, subtraction, multiplication, and division. We've already done all of those before, this year even. So this first part of the section should be hopefully, fairly easy for you. Your function operations are listed in this table right here. For addition, if I write f plus g of x, what I'm saying is that I have some function f of x and I have some other function g of x in function notation. F plus g of x simply says take the two functions and do what? Add them together, which basically amounts to a combine like terms problem. If I have my two functions and I write f minus g of x, what am I telling you to do to them? Subtract them. F of x minus g of x, which basically amounts to a combine like terms problem. Just remember that it's subtraction. We'll see how that works. If I say f, what is that dot? What does that dot represent? Multiplication. So if you see f times g of x, what am I doing to my two functions? I'm just multiplying them together. Because they're functions, that probably means I'll have to FOIL or use some sort of box method or something like that, okay? But it's just multiplication. You're distributing. And if you see f divided by g of x, what am I telling you to do? I'm telling you to divide them. Now, when can we not divide? Like what? There's something out there that we can't ever do when we're dividing. We can't divide by 0. So if I'm dividing by a function, f of x divided by g of x, then I have to make sure that this function in the bottom can't be equal to 0. Because I can't ever divide by 0. If I divide by 0 here, then probably the entire world will blow up. And I can't do that. So I'll have to figure out where g of x is equal to 0. And I'll have to say that we can't be exactly those numbers for the function once you do that division. You'll see what that is in a little bit. All right. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both functions. What values are the domain? X or y? X values. So when you see domain of the sum, blah, 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 what that's saying is the numbers that I can plug in for x, for the sum, difference, product, and quotient functions, are the same as the numbers I can plug in for x in both of the two functions that I just used. The domain of the quotient function does not contain any x value for which g of x is equal to 0. That division by 0 part right here. I can't ever divide by 0, and that's what that's saying. So once we get through some examples, all of this stuff hopefully will become more clear to you, but we are going to be talking about domain with these functions, so you have to be comfortable with that. You have to say what the domain of these guys are. So here we go. When adding or subtracting functions, it's basically a combine like terms problem. I would still use parentheses around them though, and then combine like terms. Watch out for sign changes if subtracting. That's why I use parentheses. Keep in mind that it is a subtraction problem. So, for example, find f plus g and f minus g. And then we'll talk about the domains. So first of all, f plus g means I take f of x and I add it to g of x. So I'm going to have 4x plus 7 plus the square root of x plus x. Notice the plus sign in between. That tells me I'm adding those two things together. When I'm adding things together, I just combine like terms and I'm done. So do I have any like terms to combine? Yeah, there's a 4x and an x, so I have 5x plus the square root of x plus 7. So that's your answer. Technically, you would write f plus g of x equals, yes, I do. F plus g of x equals 5x plus the square root of x plus 7. Now, if I'm doing f minus g, then I have f minus g of x, and all that does is tell me to take f of x and subtract g of x from it. So I'm going to write in parentheses 4x plus 7 minus, this time, parentheses, the square root of x plus x. Doing it that way reminds me that I'm subtracting that whole thing. To get rid of the parentheses in this case, I need to distribute the negative sign in. Because really what I have here is a negative 1 times this stuff. So I'm going to distribute that negative sign in. That way I'm not going to make a sign mistake. So this becomes 4x plus 7 minus the square root of x minus x. That just helps me remember that I subtracted. And then I combine like terms. So I have f minus g of x equals 4x minus x this time is 3x minus the square root of x plus 7. So that's the answer there. Now the other thing we have to do is talk about the resulting domains. So the first thing we want to do is look at the domains of these two original functions. Is there any number that I can't plug in to f to where I won't get an answer? Can you think of a number that doesn't work if I plug it in? That's right. If you plug in a number, you get a number no matter what. So the domain for f of x is all real numbers. If I were to graph that, I'd get a line. It goes on forever in both directions. The domain is all real numbers. What about g of x? Is there any number that I can't plug in and get an actual answer for? If I plug in 0, I get the square root of 0, which is 0. 0 plus 0 is 0. So that's a real number. What? What negative? Why can't I plug in a negative number? Because then I get an imaginary number right here. So negative numbers don't work. Even though a negative number can go there, a negative number can't go there, which means that negative numbers don't work, which means that the domain of this guy is all the positive numbers. So I'm going to write x has to be greater than or equal to 0. So now the question is, what's the domain of this guy? F plus g. The domain of this guy is going to be the domain of this and this. So basically, you put these together, and the numbers that are overlapping are the numbers that work. So what is the domain going to be here? Yeah, just the values that are greater than 0. So domain is x that's greater than or equal to 0. And again, just by looking at the function with that square root of x sitting there, if I have a negative number there, I get an imaginary result no matter what. So I can't have negative numbers on that function. And how about this bottom one? What's the domain there going to be? It's the same thing. Again, if I plug in a negative number here, I get an imaginary result. So the domain on this guy is going to be just the positive. So x is greater than or equal to 0. So what is meant by the domain of f and g is the domain of the resulting function is, the word and means overlap. If you were to draw your and graph, those two arrows point into each other. That's the overlapping region. So the overlapping region of all real numbers and the greater than 0 numbers is still just the greater than 0 numbers. So that's why our domain stayed the same here. So these are part of the answer. You have to include them. Go ahead and do the second one, f plus g and f minus g, and also the domain for each. F plus g. What do we get? 2x squared plus 8 plus x minus 3. So combine like terms and you get 2x squared plus x plus 5. Okay? And then f minus g equals okay, so two ways you can go. You can just say 2x squared minus nothing is 2x squared. I got negative x And then I have 8 minus negative 3, which is 8 plus 3, so plus 11. The other way you can go is to distribute the negative sign into this, and then you'll have minus x plus 3. And then this is 2x squared minus x plus 11, just like we got. But let's talk about the domain. So in the original function, f of x, what is the domain? All real numbers, good. All of the numbers that we could plug in work. What about the g? Also all real numbers. You can plug anything in that. You don't get any imaginary numbers as a result. So therefore, what is the domain of this function here? All real numbers. And how about this function? Also all real numbers. When multiplying functions, it's likely that you're going to have to FOIL, or at least distribute in some way. When dividing functions, you may need to use long or synthetic division. Also, you need to note any restrictions on the domain, especially when you divide. You have to say that x can't be certain numbers, because otherwise you wind up with division by 0. If you don't do that, the world could explode. So, for example, we have f and g again. And this time we're finding f times g and f divided by g. And we also need to talk about the domains of the resulting functions. So let's do f times g first. We have f times g of x equals. What that means I do is I take the two functions and I multiply them together. So x squared minus 9 times x plus 3. How am I going to handle that? FOIL. So this is going to become x to the third plus 3x squared minus 9x minus 27. Any like terms? No, so that's the answer right there. What about the domain? What was the domain in the original function f? All real numbers. What about g? All real numbers. So what about f times g? Still all real numbers. So I'll put that in my little circle there. Now we need to do f divided by g. So I write down f divided by g of x equals. F is the numerator, so x squared minus 9 divided by g is the denominator, so x plus 3. Now we just came through a chapter that taught us how to do this. So what do we do? There are no like terms. We're dividing. How do I divide like this? Long or synthetic division? Synthetic division, sometimes you're going to want to use long division. Like on this one right here, you'll want to use long division. We can use synthetic on this one though. So I set up my synthetic division. What goes in the box? Negative 3. And what goes across the top? 1, 0, negative 9. You have to account for missing terms. Then the 1 comes down. 1 times negative 3 is negative 3. I add and I get negative 3. Times negative 3 is 9. I add and I get 0. So that means that f divided by g of x equals what? X minus 3 is correct. But we also have to talk about what x can't be. Are there any numbers that x can't be? Not 0. If 0 is here, then I have 0 plus 3, which is 3. I'm not dividing by 0. Is there any number that I could plug in for x here to wind up adding with 3 to wind up with 0 as an answer? If x is negative 3, then I wind up with 0 in the denominator. And I can't have that. So I have to say x not equal to 3. This is the domain right here. It's all real numbers except for x when it's 3. So I have to say that. This is the correct answer here. All of that, including that little domain thing. So if you want to know what numbers you can't use in the denominator here to get division by 0, just take the denominator and solve for x. Set it equal to 0 and solve for x. In this case, x plus 3 is easy. We can just think of negative 3 plus 3. Sorry, negative 3 here. X has to be not negative 3, because if I add them, I get 0. So that one was an easy one to come up with. If you can't quite figure it out in your head, then just take x plus 3 and set it equal to 0, and then solve for x. Or whatever that denominator is, set it equal to 0 and solve for x. That will tell you what x can't be. Okay, next one is the same idea. Find f times g and f divided by g. Also talk about the domain for each of those results. For f times g, what do we need to do? Sort of. Distributive property, but to do it I have a box to make. 3x squared, negative 11x, negative 4, 3x, and positive 1. So that gives me, yeah. Yeah. Good. Okay. Good. So that means that f times g of x equals, how about to the third? Okay. Yep. Okay. And what about the domain? Yep, this one is all real numbers. Because the domain of this one is all real numbers, and the domain of this one is all real numbers, the domain of a polynomial is all real numbers. So there's our answer for f times g of x. F divided by g of x. I'm going to set that up. F is on top. G is on the bottom. What do I need to do? Long division here. I'm going to avoid synthetic division on this one because of this 3 in front. All of the synthetic division problems that we have practiced did not have a number in front of that x. When a number's in front of that x, things change. So if I stick with long division on this one, I won't make that mistake that you probably made when you did synthetic division here. So set this up. It's 3x plus 1 divided into 3x squared minus 11x minus 4. Now to do long division, I say what times this gives me this, and the answer is x. X times 3x is 3x squared. X times 1 is plus 1x. When I'm doing long division like this, what do I do next? Change all the signs and add. 3x squared goes away. This becomes negative 12x. Bring down the next term, minus 4. Then repeat. What times 3x gives me negative 12x? Negative 4. So I write minus 4 here. Distribute, negative 12x, and then negative 4 times 1 is negative 4. Change all my signs and add, and I wind up with 0. So that means that f divided by g of x equals what? X minus 4. But, no. You have to now say what x can't be, because if x is that number, you wind up with 0 in the denominator here, which gives you division by 0. If x is 4, then 3 times 4 is 12 plus 1 is 13. That's not 0. You have to take the denominator and do what to it? set it equal to 0. So I have 3x plus 1 equals 0. Now solve for x. 3x equals negative 1. X equals negative 1/3. So by x equals, I mean x can't equal. So actually when I do this, I should probably write 3x plus 1 is not equal to 0. 3x is not equal to negative 1. X is not equal to negative 1/3. Because if x is negative 1/3, then I have 3 times negative 1/3, which is negative 1. Negative 1 plus 1, which is 0. And then I have division by 0, and the world explodes. So I don't want that to happen, which means I need to say x is not equal to negative 1/3. And now I have, oops, I wrote it in the wrong spot. X is not equal to negative 1/3. And now I have my answer. So that's how you do these problems. Be careful with that division.